So, for this problem, we're given the graph of the velocity, right? So our function here is the velocity. And we want to answer these questions. So yesterday, we were talking about same types of problems, like particle moving along a coordinate line or a number line, and we were given an equation, and we had to do all this, kind of answer the same questions with equations, but now we're doing it with a graph. So there's less work involved as far as like taking derivatives and things like that, setting things equal to zero, solving, but a little bit more just kind of interpretation of the graph. So let's take a look at the first question here. When is the particle moving forward? So forget about the graph for a second. Just in general, what we talked about yesterday, how do we know when a particle is moving forward or to the right? What's positive? Velocity is positive, right? We know that a particle is moving to the right or forward when the velocity is positive. If the velocity is negative, it's moving backwards or to the left. So this one, we're figuring out when the velocity is negative. Well, this is the graph of the velocity. So really, like the y value equals the velocity. Well, our velocity then is positive these two places, right? These two intervals. So the velocity is positive from 0 to 1. And I'm actually going to use a bracket on the 0, parenthesis on the 1. The bracket on the 0 is because at 0 the velocity is 2, so it is positive, right? So it's included in that interval. But at 1 the velocity is 0, so it's not positive. It's not included, that's why I use the parenthesis. So the endpoints, you'll see we use the brackets on many occasions, but not at the kind of sharp turns or where the derivative is 0 or the y value is 0. All right, so this one then is from 5 to 7. That one's going to have parentheses on both because the velocity is 0 at 5 and 7. And then next part, particles moving backwards when the velocity is negative. So that happens from 1 to 5. Part C, when does the particle slow down? So again, forget about the graph for just a second. Let's think about what we know. How do we know when particles slowing down? Well, acceleration is negative, but what if it's going to the left? And the acceleration is negative. Is it slowing down?
Oh, yeah.
They have to be opposites, right? Velocity and acceleration have to be opposites. All right? Velocity and acceleration have to have opposite signs. They have to be working against each other, going in opposite directions. That's going to slow the particle down. All right? So that's slowing the particle down. If we want to see when it's speeding up, that's when velocity and acceleration have the same signs. So yesterday, the way we did that was looking at a number line and putting both velocity and acceleration on there. So let's do the same here. It might help us kind of